Hello everyone, our project was the Ergonomics of Laparoscopic Surgery. Laparoscopic surgery is a minimally invasive surgery. It requires a minimum of 3 incisions to be made up on the abdomen area. Ports are then put into those incisions to keep the holes open. One of these ports is dedicated to a camera, while the other ports are used for various tools. The camera is then displayed on a monitor so that the surgeon can see what he's performing inside. The patient advantages to this type of surgery is that it leaves less scarring because of the small incisions, there's a faster recovery time, and there's a smaller probability of hemorrhaging. The project that we're working on is an ongoing project about surgeon posture while performing laparoscopic surgery. The problem is that there's prolonged static exertion during surgery that can lead to stressful postures, musculoskeletal pain, and fatigue. Our goal was to determine shoulder endurance and recovery times for various postures. We used the box trainers at the University of Michigan Hospital Simulation Center to measure biomedical stresses associated with laparoscopic surgery. The methods that we used were an actual laparoscopic surgery observation, box trainer measurements, SketchUp, 3D SSPP, and an analysis of our results. At the Simulation Center, we measured the box trainer as well as the laparoscopic tools that are used during surgery. The box trainer has its limitations. The first is that the height is not adjustable. As you can see in this picture over here, the top of the box trainer doesn't move up or down as a bed would in an actual operating room, and the size of the box is fairly small, which would be representative of a small patient, when in an operating room you could be operating on a very obese patient. The ports are also fixed in these box trainers, and depending on the type of surgery that's being performed, the layout could need to be different than what you've been training on. There's also no need for body rotation because the monitor is right in front of where the person would be practicing. There's also a simplistic patient representation. As you can see in this picture, it's a very open area that just has a sponge in it, where in a real operation, there would be other organs and arteries that the surgeon would need to be concerned with. We used the measurements that we got from the Simulation Center to recreate the box trainer and the laparoscopic tools in SketchUp. We also added the reach limits of the 95% male and the 5% female, and we found 18 extreme hand positions. This is a picture of our model in SketchUp. As you can see, the male reach limits here, and the female here and here, as well as in this picture, the 18 extreme hand positions that the lines represent the tools. You can see there's a right and a left representing each hand. This is a graphical representation of an exercise performed by a surgeon in the box trainer. The green and the light blue colors represent the motion of the tools, and the red and the dark blue represent the movement of the hands in actual space. We then took 5 of those 18 hand positions that we found in SketchUp and took them into 3D SSPP. We considered the male and female, the 40 centimeters distance from the box trainer, plus and minus 10 centimeters. We also looked at the pronated, neutral, and supinated hand positions. We determined the percent MVC of the shoulder for each of these extreme hand positions. We then used the percent MVC to calculate the endurance times, recovery times using both the Bystrom and Franson Hall method and the Potvin method. We also calculated the variance between hand positions of the 5 extreme points. As you can see here, this is an example of our 95% male at 3D SSPP. We chose one hand position that was representative of all 5. As you can notice, between the pronated and supinated hand positions, the arms are out or closer towards the body. In this table, the blue line shows the endurance time, the shoulder endurance time, whereas the gold is showing the shoulder recovery time. We have this for the pronated, neutral, and supinated hand positions, as well as the 40 centimeter neutral distance and the plus and minus 10 centimeters. As you can see, the supinated hand position with minus 10 centimeters has the longest shoulder endurance time with the shortest shoulder recovery time. Here's the representation of the 5% female, again, with the same hand posture and hand positions. As you can see here, the blue still represents the shoulder endurance times and the gold the shoulder recovery times. This is a little more even for the female, and we believe that this is because the 5% female is so short that she requires more strength and endurance to perform all postures. But again, the supinated hand position with the minus 10 centimeters was the highest endurance time with the lowest recovery. Here are our results were that when the percent MVC increased, the shoulder endurance time decreases, and when the percent MVC is less than or equal to 15%, the Bystrom and Franson Hall method estimated longer recovery times as compared to when the percent MVC was greater than 15%, the Potvin method estimated longer recovery times. These results are shown in the 3 tables below. Moving closer to the box trainer increased the shoulder endurance time for each of the postures. But for a majority of the postures, the shoulder endurance time for the pronated hand position was less than the neutral hand position, and the shoulder endurance time for the neutral hand position was less than the supinated hand position. Our recommendations are that the surgeon maintain the supinated hand positions as often as possible and stand as close to the patient as is comfortable. He should rest his arms based on the recovery times for each hand position and allowing his assistant to hold the tools when he's doing this. The monitor should also be aligned with the surgeon to eliminate neck rotation, and there should be added foot room under the table to eliminate waist rotation. Thank you for listening. Are there any questions?